Working with data today has much more in common with software engineering than it had 5 years ago. For us at H&M, we say that data engineering is the same as software engineering. What does it mean in practice? My name is Half Scheidl, and I'd like to share the journey of the advanced analytics team at H&M. I currently work as the product area manager for the H&M group within the analytics and data platforms product area. For the last 15 years, the main focus of my career has been analytics and business intelligence, both in technical and leadership capacities. Outside of my main job, I use programming languages as a creative and artistic medium, and I'm also the organizer of the Creative Coding in Stockholm meetup. At H&M, I was part of a talented team building our first advanced analytics capabilities, and this talk is both a summary and a celebration of that journey. To summarize, today I'd like to talk about 3 topics. First, what is the big change in the way we can deliver value from data and how that change relates to software engineering? Secondly, how does that change look like for us? Did we learn something? What were the success factors? And what were the main components that this solution involved? And finally, the celebration of this journey, which is also a twist on data visualization. Could we visualize code? Could we make something expressive rather than informative out of data as a way to have fun and celebrate our success? It sounds very interesting to me, at least. I hope you enjoy. But let's start with this big change. What has happened? Well, I would argue that it's the cloud, my friends, and the brilliant minds and dedicated work of key open source projects in the data domain. Today, it's as easy to host a website in the cloud as it is to have a cluster running the most recent frameworks for data processing. It's more available and it is cheaper. However, these are still not click and run technologies, and the way to truly leverage value from them requires a new mix of competences. The expectation on data professionals is broader and in most cases expanding over topics which are typical of software engineering. Unit testing, code coverage, code complexity, release management, infrastructure as code, etc., etc. And how was it before? Traditionally, data processing in enterprise environment has been done with vendor-specific platforms, running on-premises, with significant challenges in scaling and time to market. However, it's not 2000s anymore. Data volumes and use cases around machine learning means that we need technology that are faster, can scale easily, are more powerful, and allow for iterative and fail-fast approaches. So, we need to be faster and adopt modern solutions if you want to innovate and have any kind of competitive advantage. And if we talk about innovation, we cannot RFP innovation. We are working with ideas and hypotheses which might not be feasible at all, or only prove successful after several iterations and refinements. We don't have requirements to fulfill. We don't know those beforehand. We need a strong willingness to experiment and fail, a stronger alignment around technology possibilities and their boundaries, and the willingness to build from the ground up. For data platforms, this modern approach means embracing a code and software development first approach. In practice, it means a strong focus on automation across development, across testing and release, adoption of agile methodologies such as Scrum, and a development workflow that is centered around languages and IDEs. The principles are very much aligned with both DevOps and agile mindset, typical of software engineering, and have also been described as data ops. In a simplistic comparison, I would say that modern analytics takes a code-first approach, leverages open source tech, and is a much better fit to agile methodologies. And needless to say, a better fit and more efficiently executed in the cloud. I would also like to emphasize that this is not a replacement. One is not the next generation or better option, better way of doing that. They're different use cases that each might fulfill. And if we were to focus on the left side, which is the topic today, for us at H&M, how would these points translate in practice to our journey? Well, I would say that the team that was founded and the team that was tasked to build such a platform had a very clear mission, and that's to enable advanced analytics at scale, but also had a very clear focus to provide data assets to fulfill machine learning use cases. That's the main product. To provide and maintain a platform, a machine learning platform that it's both for our own data processing, but also shared resources that are for machine learning use cases. And here you can think about primarily of clusters, but also to build it in an agile manner, meaning that it's not only following agile methodology, but from the start knowing that there will be changes, there will be changes to existing implemented features, and the development process needs to accommodate those changes and be iterative. This also means that from an organizational perspective, this agile mindset meant a clear consensus around autonomy, budget, and decision making on the both architecture, but also on prioritization. So the way of working, and I would say also key to success, was this agile fail fast approach, being willing to experiment and go back and abandon decisions, abandon options that were not proved successful. A strong focus on co-located cross-functional teams. We aim to have as much as possible the team working together in the same room. Regular and rapid sprints rhythm, sprints of 2 weeks, and trying to have this cadence over 2 years was very successful as well. A general DevOps mindset in the sense of you build it, you maintain it, and a strong focus on solutions over rules and procedures, which is typical of Agile as well. In practice, for us, that means our approach to requirements and documentation, for example, is different than what's been traditionally done in the company. And in terms of technology, there are 3 cornerstones. Python is definitely the most important of the programming languages used. Airflow was used as the orchestrator for our pipelines. And Spark is the primary data processing engine currently in use. We have used other tools and other technologies. Some are more supporting in a supporting role. For example, Jenkins was the CI/CD platform of choice. We run in Azure, so sometimes automation is done using PowerShell or Azure-specific scripting and other services from Azure. For example, the data lake is the Azure Data Lake, and part of the data ingestion, taking data into the cloud, is using Azure Data Factory. And what about software engineering then, since this is the focus of my talk? Well, we approach this as sprint goals. So at each sprint, we will have a specific goal that was closer to software engineering, and it was in parallel to other deliverables. For example, end-to-end testing, both the engine and common libraries to execute that, but also then the implementation of that across the different data assets. Automation, it's always focus, but then we took the software engineering approach of focusing on automation of certain parts of the platform during certain sprints. For example, the automation of provisioning, automation of the execution and follow-ups of unit tests, the modularization of the code base. These were made as goals, and some of these initiatives took longer than others. Another point is regarding the staffing of the team. We initially have a focus on, or a mindset that we need data engineers, as many as possible, and the team growing meant more data engineers or with varying seniority levels. I would say that within 6 months we realized that what if we bring someone that doesn't have necessarily experience with heavily like data-driven environments, but brings experience from other traditional areas of software engineering, for example, building modern websites or APIs, public-facing APIs, and so and so. And that proved to be very successful over the years. And we do recommend, and I think this was something that we could have done even more. For us now, it feels very natural that this that the way we see requirements for the role is more holistic now, and it doesn't necessarily mean that only the experience in certain areas are needed. We do see the synergies now with much more clear eyes. And if you were to take one aspect of software engineering that summarizes that, I would say that the maturity of the development workflow, as well as PR engagement for us, PR being a symbolic, let's say, looking into the process with a magnifying glass, observing the PRs and the frequency and the quality and what they actually bring to production and how the whole team engages. It's very descriptive of the team and then the team dynamics. Meaning, for example, that we noticed over time more engagement around different areas. So people that were having a very data focus, building pipelines or maintaining those pipelines, little by little getting more involved in the software engineering parts and vice versa. And since we all data driven, if I were to look into the data of this, I chose to extract some data on the pull request activities. We use Bitbuckets, but if you're more fortunate and use other source repositories, you definitely have an API available that you can extract your activities around PRs. And here I put in the black line the number of pull requests, and in pink is the comments. So PR activity has other events. I just chose comments as a way to, does it correlate with my perception of the team being more engaged? Does it correlate to us looking into certain PRs and seeing more comments or longer discussions that were also related to different topics? And it does relate to that. I'm not going to deny that we also have challenges that of PRs, that discussions that are, let's say, less of functionality, but sometimes falling into style discussions, for example, and so. We think that all discussions are positive, and it's up to the teams then to find solutions for that. But definitely also that when you're talking about data engineering and software engineering, comments that are more, let's say, broader in context and data engineering are then embracing the software engineering, and then the PR engagement reflecting that as well. One side mark perhaps is to say that this is not a performance metric. This is not something that we follow. We don't incentivize for such numbers, and that's a trap with dashboards and charts like this. But it's a way to foster discussion and ask opinions of what the team think about this. Is this surprising? Does it match our expectations? And so and so. And as I mentioned in the beginning, the third part of this presentation is a celebration. And when this presentation was initially made, it had been 2 years since the initial commit. And we take that as a way to pause and see everything that we achieved. Could we then celebrate, or could we look into this journey still looking into the code instead of listing bullet points of this and that feature? What I did then was to say that yes, you could do it, and I chose the commits. So you can also extract data from the Git log. It's a Git command, and that relates to the famous GitHub activity chart. You're familiar with that? This shows in every contributor's page. But it's a bit boring, right? It's a bit boring, and it doesn't mean much. It means that these days there are more commits. It doesn't necessarily inform the quality or the nature of those commits. But could we make this more beautiful? Can we make something that is perhaps not informative, that we don't draw conclusions, but it's reflecting this code-driven approach, and perhaps a way to celebrate our 2 years? And this is what I did. I hope you enjoy. It's very simple. So first, export the Git logs. little squares and paint them green and change the saturation. This is perhaps the recipe to make a GitHub chart. By doing this, very few lines of code, about 30 lines of code, you get something that looks like this. This is actually a screenshot of my page running. This is JavaScript. Then from here, 4 steps to make this more interesting. First, rotate each square a little bit, use a noise function. Very interesting part of computer graphics, noise functions. And then after this rotation, just make them longer into rectangles. And then shrink them at every iteration of the loop, make them shorter. And this already creates a organic feel that this looks like paint was dropped onto the screen. And already by now we lose completely this sense of what happened when, which is intentional. We want to make something that is aesthetic, not necessarily informative. And finally, just change the color, remove the GitHub shades of green, and I chose blue. And voila, that's done. This is our 2-year anniversary poster for data engineering. And this is a mock-up of the same chart. This open source code was done in JavaScript. If you don't use JavaScript, maybe it's a way to have fun with it. If your team is already using JavaScript, try to do something with Python using another data set. The options are limitless. Just do have some fun with it. So if we're to summarize our journey, success factors and lessons learned, Agile, DevOps, and the composition of the team, definitely key components of that. And the learnings that the initial focus on high value over holistic architecture proved successful in enabling the products. Meaning we didn't aim to build a data platform. We meant to solve business problems or find optimization problems that we could fulfill by using modern data platforms or modern data processing and machine learning. Adopting and embedding software engineering practices is a continuous effort. Aim for keeping a positive spiral, meaning that aim to, even if it's small increments and working around technical debt or bringing new software development principles is the way to go. Depending on the maturity of the team, this is very important because the data asset creation or data processing that are more related to output of data assets will be more important than bigger in scope and visibility. This has less visibility, but it's something that needs to be done all the time. Be bold and unorthodox about staffing. Do consider that experience in different domains can be helpful. Trust the competences of the individuals. Do not be so particular about the programming language or the experience with business intelligence, or even if it's with the modern technologies. People working with tech know that the ability to learn and the mindset, the principles are more important, and that's what usually our best colleagues are valued for, not necessarily for their experience in a particular tool. Use that to your advantage. Be data-driven, but watch out for proxy measures. So that means we are building data processing solutions, and with the tools and the methodology, the workflow that we use, we have a chance to extract a lot of data and get insights from that. But those are the insights in themselves. They're only valuable in context, meaning that when you look into the agile processes or the statistics from the workflows, or like I did, I extracted the Git logs and also the PR data. Those are relevant in context only. In it alone, they might not tell the whole story. And have fun. Try some creative coding as a way to bring the team together, or to increase literacy in code around the non-tech roles, the product owners, the product managers, or then as a way to explore and really go deeper into understanding differences between languages, differences, why JavaScript works the way it does in Python and Java, for example, and using that to challenge the team by doing something fun. And creating a poster visualization is my suggestion. I think it was fantastic. Thank you so much for joining me today. I hope this was informative, but also interesting, that it sparked some curiosity in you. And it's a pleasure talking to you today. Thank you.